Today's goal, write a function when you're given the zeros of that function. And let's hop right into this first example. Write a function in standard form that has these zeros, -4, 1, 3, and 5. Well, quick introduction to this. What we want to be able to do, we want to be able to write this final answer that's in the f of x form. And I'm just kind of making up like an x to the fourth plus blah, 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 x third plus blah, 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 x squared plus blah, 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 x plus blah, blah, blah. So that we want an answer that looks in this form right here. That if we were to graph it, like on Desmos, or graph it however, it would cross the x-axis at -4, 1, 3, and 5. So you can imagine kind of what this graph would have to look like. I'm imagining kind of this W shape that crosses through -4, and 1, and 3, and 5. So we know what the zeros need to be here. The question is, can we write the actual function that would contain all of those zeros? And that's what this video is going to show you how to do. Now, before we get started, a quick review on one thing. We need to review what happens when you multiply variables together with different exponents. Right off the bat, if you take x times x, or I'll even put this one in parentheses, x times x, I need you to realize there's an invisible one here, there's an invisible one here. The rule is you add together the ones, the 1 plus 1 is a 2. And so x times x is equal to x squared. Okay, that makes sense. That's kind of the definition of x squared, is x times itself. Now, you can keep going with this. If you took an x times x squared, that would bump up the degree. We would take 1 plus 2 is equal to 3. X times x to the third, that would bump this up 1 degree. It would make this equal to x to the fourth. X times x to the fourth, if we multiply these together, that would bump this up 1 degree, make it x to the fifth. So quick review, that's going to show up time and time again today. So quick review on how to multiply these variables together. All right, so let's jump into this example. Well, there's a very important rule that we need to follow in order to come up with this answer. The rule is if you have any number, we'll call it r, and it's a zero of a function, then there's a rule that says x minus r is a factor of that function. And to put that into practice, here's what we do. These are all of these zeros that we have. If -4 is a zero of a function, then I know x, you actually change the sign of this. If it's a -4, I'd make the factor x plus 4. I know that x plus 4 is a zero of the function, is a factor of the function if -4 is a zero. Likewise, if 1 is a zero of a function, I know x minus 1 is one of its factors. If 3 is a zero, I can say x minus 3 is one of its factors, and the same with 5. If 5 is a zero, then x minus 5 is one of its factors. What this means is we could write a function now. If I could find the function that has all 4 of these factors, then it's a guarantee that function would contain all 4 of these zeros. Kind of the bottom line, what you need to know is that the zeros of a function and the factors of a function, in essence, they're really just opposites of each other. If the zero is -4, the factor is x plus 4. If the zero is 1, the factor is x minus 1, and etc., on and on. So now we just have to simplify this to get the answer. And I'm going to simplify this first, and then I'll go in later. I'll show you on Desmos how that this is true, that it actually works. My advice on these, I think these are a lot easier to simplify if you start on the right-hand side and kind of work from the right to the left. So I'm going to times x minus 3 times x minus 5. Listen, this is called the FOIL method. I'm going to take this x times this x, and I'm going to take this x times the -5. Now remember, x times x, we just practiced this. That's x squared. X times -5 is -5x. So I distributed this x into the parentheses next to it. Now I'm going to do the same with this minus 3. I'm going to take minus 3 times x and minus 3 times negative 5. Two negatives make a positive. And when I combine like terms, I'm left with x squared minus 8x plus 15. All right, and I don't know too much about this x squared minus 8x plus 15, but I do know, I promise you, if you were to graph this right now, x squared minus 8x plus 15, it would cross the x-axis. It would have zeros at 3 and 5. All right, so let's continue now. Let's kind of pull just one at a time. Let's pull another one of these factors down. Let's take this x minus 1 and pull it down. Now we need to multiply x minus 1 times x squared minus 8x plus 15. Well, this is technically not called a FOIL problem anymore. I try not to think of these as FOIL problems. I just try to think of them as like double distributing. I'm going to distribute the x times x squared, x times 8x, and x times 15. That's just going to bump the degree of these all up by 1. X times x squared becomes x to the third. X times negative 8x becomes negative 8x squared. X times 15 becomes 15x. Notice each of these, the degree just went up by 1. But now I'm also going to distribute the negative 1. Negative 1 times x squared. Negative 1 times negative 8x. Two negatives makes a positive. And negative 1 times 15 is a negative 15. Now this one has a few more like terms that I can combine. Namely, I have a negative 8x squared minus a 1x squared, a 15x plus an 8x, and then this little negative 15 is out here by itself. Oh, sorry, you couldn't see that. There you go. And so I don't know exactly what the graph of this would look like, this cubic expression here, but I do know if I graphed it, I promise you, and try me if you don't believe me, if I graph this right now on Desmos, I guarantee you it would cross the x-axis at 5, 3, and 1. Okay. Now a lot of the homework problems I'm going to give you are only going to have 3 zeros. So a lot of the homework problems I give you, you'll kind of like end right here. This will be your final answer. But I decided to make our example a little bit more challenging. This example also has a fourth factor that we need to multiply by. Okay. I still have this x plus 4 I need to bring down. Now I need to multiply all of this by x plus 4. And this will give me my final answer. I'm going to distribute the x. X times x to the third. X times 9x squared. X times 23. And x times negative 15. Notice when you multiply all of these by x, it just makes the degree go up by 1. Then I'm going to distribute the 4. I'm now going to times all of these things by 4. Now I'm starting to run out of room, so I'm going to actually organize this. When I do 4 times x to the third, I get 4x to the third. I'm actually going to organize that right underneath my negative 9x to the third. I'm going to write it right here. 4 times negative 9x squared, this would be negative 36x squared. 4 times 23x, that'd be positive, 92x. And then 4 times negative 15 is negative 60. Now the way I lined these up, I actually lined these up perfectly, where now I can combine my like terms rather easily. Negative 9x to the third plus 4x to the third is negative 5x to the third. 23x squared minus 36x squared is negative 13x squared. Negative 15x plus 92x is 77x. And don't forget about my minus 60. Guess what? This is my final answer. And I'm going to prove to you in a second. We're going to get on Desmos here in a second. We're going to graph this function, and I guarantee you this function, this answer, when I graph it, will cross the x-axis at negative 4, 1, 3, and 5. All right, let's get on Desmos. Whoops, it probably looks something like this is kind of what it looks like, would be my guess. Sorry about that. All right, let's get on Desmos, check that out, see how it worked. All right, and here is a look at example number 1 now on Desmos. So
what I was trying to do, I was trying to write this function that had zeros at -4, 1, 3, and 5. And let's just here's how we would check our final answer. What we came up with is x to the 4th minus 5x to the 3rd minus 13x squared plus 77x minus 60. And look at that. We know we got the right answer. Fits like a glove. Alright? So that's one way you can check your work, make sure that you did this right. And I want to show you this as well, just to kind of prove to you that this factor form works. If you were like the original factors of x plus 4 times x minus 1 times x minus 3 times x minus 5, here's kind of proof that this factor theorem really works. That if the roots are -4 and 1 and 3 and 5, that if you write a function with these factors, okay, you can see how that passes through, guaranteed to pass through all 4 of those zeros. Yeah, so proof that first example works.
And let's throw in a check problem for you to try on your own. Write a function with these zeros. So if these are my zeros, then my factors would be in essence the opposite, x plus 5, x plus 5, x minus 3. All right, go ahead. I want you to try this on your own. Try multiplying all 3 of these together, and let's see what answer you get. Yeah, go ahead and hit pause, give this a shot, and then we'll go over the answers. And here's kind of the first result. When we multiply these last 2 factors together, we FOIL them. We distribute the x, get x squared minus 3x. We distribute the 5, we get 5x minus 15. That simplifies to x squared plus 2x minus 15. Now, we need to carry down this factor of x plus 5. And now we need to multiply again. And when we multiply these by each other, we start by distributing the x. All right, that's these 3 answers right here. We times all these by x, so we got this. Then we're going to distribute the 5, and we get these 3 answers when we times all of these by 5. And the things that we can combine together, the 2x squared and the 5x squared make a 7x squared. The 15x plus the 10x makes a negative 5x. And so final answer is right here. Let's plug this into Desmos and check and see how it worked out.
Okay, and let's check that. We'll check our check problem on Desmos to make sure we did it right. We got an answer of x to the 3rd plus 7x squared minus 5x minus 75. And we can see right here that it absolutely works. The zeros are at -5, -5, and 3. Now something really interesting. Notice that the -5 shows up twice on the zeros list. Okay, the -5 here is called a double root. The graph bounces off of the point -5 comma 0. Okay, it comes up here, it bounces off -5, 0, and then kind of turns around and comes back. So -5 comma 0 counts as 2 roots, or 2 zeros. Okay, even though in a graph you could say, wait, it only touched the -5 once, you're actually supposed to count this twice. Okay, so right here, this 0 counts twice. It shows up as -5 and -5, and then this 0 only counts once, it shows up as 3. So the original problem was zeros of -5, -5, and 3. Here's what the double root is going to look like on a graph. If the -5 shows up twice on your list, then that means on the graph it's going to come up, bounce off the -5, and turn back the other direction. All right, hey, best of luck on this assignment. Take care.